Here we are, the 2016 Practice AP Calculus AB exam. We are going to cover free response question number 5. If you've been with us before with previous videos, welcome back. If you have not, and you only want to see how question 5 is done or check your work, welcome. Not welcome back, but just welcome. Okay, when I go over problems, I might take a little longer, not because I don't know how to do them, but sometimes there are areas that I like to explain things because, hey, you're here because you want to see how it's done, most of you. Okay, so sometimes there's some explanation, not all the time, but sometimes there is. So, 2 things here. First, follow me, because that is the only way you will get notifications of when I put up videos in the future, like free response question number 6. Okay, also like the video, that helps me. Following me helps you with notifications, but liking the video helps me. And while you're down there ringing that bell, liking this video, if you want to throw something in the comments as far as maybe a question you have or even a test in particular that you want to see, maybe the 2008 test, you know, I'll take that into consideration as we move forward with future videos. And maybe I'll do one that you're requesting. All right? So, there is no calculator. Whoa. Whoa, whoa. Let's get started with free response question number 5. Number 5 reads, for the interval of t from 0 to 24 inclusive, being hours, the temperature inside a refrigerator in a kitchen is given by the function w that satisfies the differential equation dw dt equals 3 cosine t over 2w. Wt is measured in degrees Celsius, and T is measured in hours. At time T equals 0, the temperature inside the refrigerator is 3 degrees Celsius. Okay. A asks us to write an equation for the line tangent to the graph at y equals Wt at the point where T is 0. Use the equation to approximate the temperature inside the refrigerator at a T value of 0.4 hours. All right, great. I tell my students constantly, anytime they say write an equation for a line or a line tangent, we're automatically thinking y minus y1 equals m times x minus x1. All right? And for this equation, we need 3 things. We need a coordinate, an x and a y, and then we need a slope, which is typically the longest or most work we're going to do in the problem is finding the slope. However, if we look here, this isn't going to be that bad at all. How come? Okay, where's our x and a y? Okay, well, at this point where time is 0, that's where I want the equation. Well, at time 0, the temperature is 3. So at time 0, my temperature is 3. That's our coordinate. That's our x1 and our y1. So it is y minus my 3, okay, there, equals, I still don't know m, and that's fine, times x minus 0. Or I could just say that's going to end up being just times x, because x minus 0 is x. So I need to find the slope. My slope, okay, they've given us this here. Our derivative is slope. Okay, that's dw over dt. And that's given to us as 3 cosine of t over 2w. Again, I want it at this point when my t is 0 and my w is 3. So let's just plug in, all right, into our derivative, the t0 and w3. 3 cosine of 0, because that's time, over 2 times my w, which is 3. And, you know, I'm starting to write at an angle here, so I don't know, I haven't had my coffee yet this morning. You can see down in the bottom right, it is October 28th, 3 days till Halloween, and it's only 8:07 a.m. All right, so let's evaluate this right now. I'm going to evaluate this right now. Cosine is 0. Again, in the previous video, I mentioned when it comes to trigonometry, you either should know your unit circle or the graph of cosine in your special triangles that measure 45, 45, 90, or 30, 60, 90. In this case, I like to refer to the graph of cosine, which I know is the cup. Cosine is the cup. Okay, at 0 degrees, okay, I'm up here at 1. The cosine of 0 is 1. Okay, so this would be 90 degrees. This would be 180 degrees, -1. This would be 270, and this would be 360. It comes back up to 1. But they want this point right here. Okay, here's where y is 0. When cosine is 0 degrees, the output is 1. So in for this, it's 1. So let's go back this way. It's 3 times 1, which is 3, over. Well, 2 times 3 is just 6. Okay, so our derivative, our slope, okay, our m value is 1/2. That goes in right here. So we're still not done with this problem. Okay, let's clean this up, this equation. I've got y minus 3 equals 1/2 of x. And if I wanted to, I can add 3 to both sides. Okay, that's if I add 3 to both sides. Okay, and this is the equation. Okay, so write the equation of the line tangents. That's done. Check. But they ask us a second thing here. Use that equation to approximate the temperature inside the fridge at 0.4 hours. So I want to solve this at a t value of 0.4. So we're going to continue. All right? I'm going to say y equals 1/2 of 0.4 plus 3. Now, you'll see that a lot of the algebra, even though we don't have a use of a calculator, a lot of the algebra is easy here. So 1/2 of 0.4 is 0.2 plus my 3, 3.2. I don't think they're asking for a label or anything, but use the equation. Well, for finding W, I guess that would be degrees Celsius. But it's not asking us to write that. But since we're smart, we're going to put that down right there. So there you go. That was, a little bit lengthy with the explanation, but it's problem number 5. So let's continue. 5b says, find y equals w of t, the particular solution to the differential equation with initial condition w of 0 equals 3. Oh, I knew this was coming. I knew this was coming. How did I know? Well, let's move back here. The moment I saw this, I thought to myself, they're probably going to have us do separable differential equations at some point. And here we are with B. So let's write this down. dw of dt equals 3 cosine of t over 2w. Okay? So if I'm going to solve this, I want to get my w and dw on one side, my t's and dt's on the other, and then I'm going to have to integrate both sides. There are not going to be any bounds because we have an initial condition. When t is 0, w is 3. All right? So we're going to be able to do just fine here, just fine. And it's not really going to be that bad the way I'm looking at this. Let's multiply both sides by 2w. Bye-bye. So this side gets multiplied by 2w. All right? Now let's multiply both sides by dt. Bye-bye. And to multiply this side by dt. So let's write what we have right now. I've got 2w dw on this side equals, okay, 3, I'm going to write this here and put a little space here for a reason, cosine of t dt. I've got to integrate both sides. I should really bring up, I don't think that's going to matter. Integrate this side, and I'm going to bring my constant on the outside of my integral. Okay, it's a constant, so I'm just going to just shoo that out. All right? So let's differentiate both of these. Okay? Now, when I say differentiate, I mean let's integrate both of these. This would be W squared plus C. Remember, we'll call that C1. There are no bounds. All right? Equals 3. Well, I integrate the sine of t to get cosine of t plus C. There's some other constant. All right? Here we go. I'm going to bring one constant over to the other. So let's subtract C1 from both sides. Boom! And I got W squared equals 3 sine of t. Oh, it's not equals. Huh. That is plus. Okay, if I have one constant, I combine it with another, it's still a constant. All right? So if I need to find the particular solution, I need to find a value for C. And that's what we're ultimately going to do. At this point, let's throw in, all right, I'm going to throw in my initial condition. Remember, when t is 0, W is 3. So when t is 0, W is 3. All right, so I have 3 squared equals 3 sine of 0. All right, again, if you, plus C, let's not forget that. That's what we're actually solving for. If you know your graphs of sine of cosine, or you know the unit circle, the sine of 0, sine is the S. Okay, when sine is 0, the sine of 0 is 0. Okay, 90, 180, 270, 360. Comes up to 1, down to -1. So the sine of 0 is 0. 3 times 0 plus C. This is 0 plus C is just C. I could swear that's 9. 3 squared is 9. So, all right, I have C is 9. I'm going to put this back into this C right here. So I've got W squared equals 3 sine of t plus 9, because that's where my C was. I still got to solve for W. All right. There you go. W equals the square root of 3 sine of t plus 9. And that's it. Okay, that is it. That, my friends, is it. All right? 5C reads, the temperature in the kitchen remains a constant 20 degrees Celsius for T being greater than or equal to 0 and less than or equal to 24. The cost of operating the refrigerator accumulates the rate of $0.001 per hour for each degree that the temperature in the kitchen exceeds the temperature inside the refrigerator. All right? Write, but do not evaluate an expression involving an integral that can be used to find the cost of operating the refrigerator for the 24-hour interval. All right? So, it costs that much, okay, that 0.001 per hour for each degree that the temperature in the kitchen exceeds the temperature inside the refrigerator. Okay. All right, here we go. I like the fact that we have to write an expression without evaluating it. We don't have a calculator, which means this will be very difficult for us to evaluate, considering this is a free response question without a calculator. So, first of all, I need to add up all the temps, so to speak, that satisfy the condition that the temperature in the kitchen exceeds the temperature inside the refrigerator. What is the temperature? The temperature in the kitchen is 20. I know we got 20. Okay? But what is the temperature of, what is the temperature of the inside of the refrigerator? The inside of the refrigerator, I'm going back to 5, the problem itself, is given by the function W. Okay, where W of t, that's our function, is measured in degrees Celsius. All right. So let's go here. So I'm going to take my 20 and I'm going to subtract W of t. Okay? And I'm going to see, okay, remember, we want the bigger function minus the smaller function. And why are we doing that? Because the temperature in the kitchen exceeds, which means it's bigger than inside the refrigerator, which is our W of t right here, okay? So anytime we have this situation where 20 is the bigger, I want to add all those times up. I want to add up all those hours from 0 to 24. How come? There. Okay? Because in that 24-hour interval, all right, I'm going to take this. That will give me all the total hours, okay? And how much is it per hour? Because they want to know the cost. Well, I got to multiply it times how much we pay per hour, which is 0.001. I am missing right now intentionally one thing, that I say you will lose points if you don't write it. Anytime you write an integral, you better put your dummy variable there. Okay, if you want to put this in brackets or parentheses, you can. This is an expression because there's no equal sign. This is what they want us to write. Write an expression, but do not evaluate. Wunderbar. Ja. Here you go. We're all set. That is fantastic. That wasn't bad. And just like 4, it was only 3 parts. There was 5A, 5B, 5C. Only 16 minutes. All right? Video is done. Okay, video is done. That was a really, really easy part C. All right? Like the video, that helps me. Follow me, that helps you. And throw down a comment if you want to see something else done as far as these AP Calculus AB exams, because I am here to help. All right? Look at Halloween's in like 3 days. I hope you're going to dress up as something crazy, but not too crazy. You know, remember, there's still small children out there. And you know what? Be nice to people. When you walk by someone on Halloween, just tell them, even the little kids, just be like, I love your costume, and just see how they just perk right up, man. They just like get so proud. You know what I mean? Trust me. These little kids, they look up to you older guys. You know what I mean? So the nicer you are to them, the better they will be when they grow up, and that's how we create a better future. Because, hey, I'm in my 40s. My generation already screwed up. We lost our chance to make the future better, but you can. And you know how you can start? By liking the video. Oh, shameless plug. I will see you guys later for free response question 6. I'm sorry, there's like 8 people in here all laughing that I did that. I'm sorry, it's just a dumb dad joke. I'll see you for free response question 6. Bye-bye.